Okay, we are given the diagram. They said squares are inscribed in another squares by joining the midpoint as shown. Find the ratio of area of MNPO to that of ABCD. Before I solve it, let's look at this diagram. Plane. So remember, this is the midpoint. So assuming we have this x, this x, this is x root 2, yes, by our 45, this is 45 degrees, and isosceles triangle. So this hypotenuse is x root 2. So have you seen that the length here, the total length of this, the circum square is 2x, while this is x root 2. So even if you try inscribing another square, if you inscribe another square, so the length will now be x. Yes, because I told you they differ by root 2. So if you divide this by root 2, you get this. If you now inscribe another one in that, the length will be x over root 2. So that's the logic we are going to use here. So assuming, okay, let's assume, let's term n be the side of the secum square. That's the longest side here. So you see that term n is always the first one, the smallest one, times the common ratio n minus 1, because I told you this will form a geometric progression. Yes, where r is root 2. So where n is the number of squares involved, So that's how you solve that kind of question. Just know that whenever you inscribe a square in a square, that the ratio of the side is 1 is to root 2. Okay, from what we've done, you see that we have how many squares? N is 5 here because we have 1, 2, 3, 4, and 5. So n is 5 here. And since we're asked to find the ratio of areas, so we're going to use the formula relating ratio of areas of similar shapes, because they are squares, the two are squares. So we know that ratio of area of MNPO to that of ABC, the ratio, okay, is equal to the ratio of the squares of the lengths. Yes, because the ratio of area of similar shapes is always the same as the ratio of the square of their length. So area of square MNPO, the side will be T2. Remember, I told you that the sides form a geometric progression. So we are using T as term. So why this is T5, as that's the length of the longest square. So all squares. So, and remember our geometric progression like this. So when n is 2, so this is T1R over T1R raised to the power 4 squared. So this is now 1 over R3 squared. And this is 1 over R3, okay, which is R6 r raised to the power 6. So well, remember I told you their common ratio is root 2. So this is 1 over root 2 raised to the power 6. So our answer is 1 over 8. So the ratio is 1:8. So whenever we inscribe squares this way, the sides form a geometric progression with common ratio root 2. So we use combined knowledge of similar shapes, that if the ratio of areas of two similar shapes is the same thing as the ratio of the squares of the lengths. So that's why we squared. And also the sides are in geometric progression. So that's how with common ratio to root 2. So thank you.